Hello everyone, my name is David and today I'm for this video. Let's get started. Nothing in the universe is that in the Milky Way, billions of stars orbit the galactic center. Sun like our sun are pretty consistent, keeping a distance around 30,000 light years from the galactic center, completing an orbit in every 230 million light years. This distance is not an orderly ballot. It's more like a skating rink filled with drunk toddlers. This chaos makes the galaxy dangerous. Our solar neighborhood is consistently changing. The stars moving hundreds of thousands of kilometers. Only vast distance between objects protect us from danger out there. But we might get unlucky in the future. At some point, we'll encounter a star going supernovae or a massive object passing by and showering Earth with asteroids. If something like that would be to happen, we would like to know thousands, if not millions of years in advance. But we can't still do much about it unless we move the whole solar system out of the way. To move the solar system, we need a stellar engine, a mega structure used to steer a star through galaxies. It's just kind of a thing that may be built by advanced civilization with a Dyson sphere technology that's thinking about future millions of years above them. But how do they possibly move hundreds of thousands of objects in the solar system? The good news is we can ignore all of that. We only need to move the sun and other good stuff by gluing it to gravity and it will follow it wherever it decides to go. There are a lot of ideas about what a solar engine might look like and how it would work. We picked two grounding our current understanding of physics that could be built in theory. The simplest kind of solar engine is the Skadov structure, a giant mirror. It works the same principle as a rocket. Like rocket fuel, like photons released into the solar radiation that carry momentum, not a lot but a bit. For example, if astronauts turn a flashlight into space, it will push them backwards very slowly. A stellar engine would work a little faster than the flashlight because the sun produces a lot of photons. The basic idea of a Skadov thruster is to reflect the half of solar radiation to create thrust and slowly push the sun where we want to go. For the Skadov thruster to work, it must be kept in the same place, not orbiting the sun. Although the sun's gravity will try to pull in, it will be supported by radiation pressure, which props the mirror up. This means the mirror will have to be very light, made of micron-thin reflecting foil from materials like aluminum alloys. The mirror's shape is important too. Enveloping the sun in a giant spherical cell would work because that would focus light into the sun and heating it out and creating all sorts of unwhelming problems. Instead, we use a parabola, which sends most of the photons and the sun in the same direction. To prevent accidentally burn or freezing Earth, too much or too little sunlight, the only safe place to leave a Skadov structure is over the sun poles, which means we can only move the sun vertically in a plane of solar system in one direction of the Milky Way, which limits our travel options to big. But that's basically it. For civilization capable of filling a Dyson sphere, this is relatively simple endeavor. Not complicated, just very hard to build. At full throttle, the solar system could probably move around 100 light years over 230 million years. Only a few billion years it gives us a near complete control over the sun's orbit in the Milky Way. But in the short term, that might be not fast enough to dodge a deadly supernovae. That's why we thought we could do better. So we asked if we can design a faster stellar engine for this video. And we did, and wrote a paper about it. We're going to call our new stellar engine the Kelvin thruster. It works a lot like a traditional rocket. Shoots exhaust one way to push yourself another. A fast space station transformed by, powered by the Dyson sphere that matters from the sun. It shoots very fast jet of particles, nearly 1% the speed of light, out of the solar system. A second jet pushes the sun along like a tugboat. The Kelvin's thruster requires a lot of fuel, a million tons per second. To gather this fuel, the thruster uses very large electromagnetic field funnel hydrogen and helium from the solar winds into the engine. The solar wind doesn't provide enough fuel though. That's where the Dyson sphere comes in. Using its power, sunlight can be refocused to the surface of the sun. The heat cools small regions to extreme temperature, lifting billions of tons of mass of the sun. This mass can be collected and separated into hydrogen and helium. The helium is burned explosively in the thermonuclear fusion reactors. A jet of radioactive oxygen, temperature nearly a billion degrees, is expelled and becomes our primary source of propulsion of the solar engine. To prevent the engine from crashing into the sun, it needs to balance itself. To do this, we accelerate the collection of hydrogen with electromagnetic fields by particles accelerated and shoot a jet out of it. This balances the thrust and transfers the thrust of our engines back into the sun. As little as a million years, this engine can be moved by the sun by 50 light years, more than enough to dodge a supernovae. At full throttle, the solar system can be completely redirected at its galactic orbit in 10 years. But what if we use the sun this way? Unfortunately, the sun is so massive that even billions of tons of material barely scratch the surface. In fact, this megastructure will actually extend out the sun's life, since lowering the mass burn slower, keeps the solar system inhabitable for many billions of years. With Kelvin's thruster, we turn the entire solar system into a spaceship. For example, by orbit backwards the galaxy and colonizing hundreds of thousands of stars as we pass by them. It may be impossible to escape the galaxy entirely and expand beyond the Milky Way. Stellar engines are kind of machines built by civilization, not thinking in terms of years or decades, but eons. Since we know that the sun will die one day, a stellar engine could allow us to the far future of descendants of humans to travel without ever having to adventure to the terrifying dark abyss of the interstellar space. Until we build a stellar engine, we are adrift and subject to the whims of galactic sea. We may not like where it leaves us. Maybe our descendants may set sail and become a stellar species for millions of years to come. So that's the end of the video. Thank you for listening. Goodbye.